Today we're going to be talking about Magnetars. No, not Pokemon or Centaurs, Magnetars, the most powerful magnet known in the entire universe, and also a star that has died and become a really special type of neutron star.
The sun is a big ball of gas, about double the gravitational force of Earth. On Earth, we have this nice solid crust to keep us from accelerating towards the molten core. But what about the sun? What keeps the gases pushed out in a nice sphere? Well, inside a sun, fusion events are happening. Hydrogen atoms are combining to form helium, and when this occurs, they're huge explosions. It's the outward blast from these explosions that keep everything from collapsing. Basically a friendly tug-of-war between gravity and nuclear bombs. But at some point, all of the hydrogen will have been fused to helium, and then the helium will have been fused together into oxygen and carbon till at some point the fuel runs out and gravity wins.
During the collapse, there are no rules. Gravity pulls particles towards the center of the star at speeds which decimate everything. Protons, electrons, all neutrons now. This ball of neutrons is like the mass of the sun plus 2 more suns squashed together into a tiny ball the size of Paris. And with all that mass comes a whole lot of gravity. If you were walking on one of these stars, which you wouldn't because you'd be dead a few thousand miles ago, but if you were and you tripped, you would fall at a speed of 10,000 miles per hour. As we know, those electrons and protons that died in the Great Collapse were spinning. And I guess there are some rules in this chaos because conservation of angular momentum still applies. So all the atomic angular momentum encompassed in 3 suns of mass is now combined in the neutron Paris.
We're gonna solve that now.
Just kidding, no we're not. Professionals with salaries have done that for us. They estimate the neutron star rotates about a few hundred times per second. That's about the speed of your common kitchen blender. Paris! These name brand neutron stars have impressive magnetic fields of their own. Magnetic fields are usually reported in Gauss. Can you tell me, Phil, is that a CGS unit or an SI unit? That's wrong. It's a CGS unit. Now, what exactly does Gauss measure? Wow, 0 for 2. Gauss describes the term B, which is known as magnetic induction or magnetic flux density or just magnetic field. Just like with angular momentum, magnetic field of the original stars don't disappear when they become neutron stars. They mainly are compressed down into their new tiny size, which makes their magnetic flux densities insanely high. But remember, these are just your average run-of-the-mill neutron stars. Let's go over some numbers, shall we? The average magnetic field on Earth is about 1 Gauss. An MRI is about 1,000 Gauss. The strongest man-made material, 100,000 Gauss. At about 1,000,000 Gauss, we reach the limit of our materials. They'll start to break apart. The neutron star, 1 trillion Gauss. A magnetar, 1 quadrillion Gauss. That's 1,000 trillion Gauss. About 1 in every 10 neutron stars becomes a magnetar. The specifics of how this happens is still up for debate. Some theories include something to do with the proton areas that are still sometimes present on the outer edges of the neutron star, or possibly from binary interactions between a pair of stars when one of them collapses. Let's discuss the physical phenomena which occur as you approach a magnetar. At 100,000 miles away, about half the distance between the Earth and the Moon, all magnetic strips are white cleared. A little closer, and hard drives, white cleared. Things really start to get interesting as you get within 600 miles of a magnetar. In atoms which have valence orbitals with paired electron spins, electrons will jump up to the next energy level to be able to align with the magnetar's magnetic field. The lower level electrons don't have that option. Opposite spin electrons are repelled by the magnetar, while same spin electrons are attracted causing an electron cloud dipole, and all your nerve impulses are shot. Not only that, covalent bonds just fall apart when the electron cloud stretches. We and everything else would just atomize, atomically dissipate into a magnetic field. As you get closer and closer, atoms stretch more and more until they become pencil-thin rods. But please, remain calm. You would have already died from the Magnetar's intense radiation and the high-speed particles stuck in orbit around it. Luckily, the closest known magnetar is about 9,000 light years away in the constellation Carina.